26 million gallons. That number barely fits in the mind. It's more fuel than some countries consume in a day, flowing from a single place, without pause, without sleep. Right now, as you're watching this, pipes are humming, furnaces are roaring, and crude oil is being transformed into the gasoline that keeps America moving. Not in theory. Not on paper. But in real time. This is the inside of America's largest refinery, where energy is forged at a scale that feels almost unreal. Long before electric dashboards and charging stations became part of the conversation, America ran on combustion. The growl of engines, the smell of fuel, the promise of speed and distance. Along the Texas Gulf Coast, where shipping lanes meet endless pipelines, a refinery began rising in the early 1930s, built for a nation that was discovering how deeply its future depended on oil. Texas City was chosen not for comfort or beauty, but for access. Deep water ports. Rail lines. Crude oil flowing in from every direction. What started as a single refining operation slowly expanded through decades of demand, war, boom, crisis, and reinvention. The facility survived World War II, when fuel became a weapon as powerful as any bomb. It endured the oil shocks of the 1970s, when gasoline lines wrapped around city blocks. It witnessed tragedy, including the devastating 2005 explosion at a neighboring site that forced the entire industry to confront safety at a new level. Out of those lessons came redesigns, stricter controls, and a renewed focus on preventing catastrophe in places where pressure and heat never rest. In 2013, the refinery entered a new era. Marathon Petroleum acquired and integrated the site with nearby operations, creating a single vast refining system along Galveston Bay. What emerged was not just a plant, but an industrial organism. Nearly 1,000 acres of steel, valves, towers, furnaces, and sensors. Over 1,500 workers, plus contractors and specialists, operating around the clock. No closing hours. No holidays. Fuel doesn't wait. Every day, more than 630,000 barrels of crude oil enter this complex. That's over 26 million gallons, delivered by massive ocean-going tankers and pipelines stretching thousands of miles. Some crude arrives thick and heavy, rich with sulfur and metals. Some is lighter and easier to process. Every barrel tells a different geological story, formed over millions of years, now facing its final transformation. Before gasoline even exists as a concept, the crude must be tamed. It flows into enormous storage tanks, some capable of holding 500,000 barrels each. Inside, the oil rests and warms, heated gently to reduce its thickness so it can be pumped without resistance. Water settles out. Sediments drop. But this is only the beginning. Next comes desalting, a process that looks deceptively simple and is absolutely critical. Crude oil contains salts dissolved in trapped water, and those salts are silent killers. Left untreated, they corrode steel, poison catalysts, and eat refineries from the inside out. So the oil is mixed with fresh water and subjected to powerful electric fields. The water droplets merge, pulling salts and impurities with them, then separate and drain away. What remains is cleaner oil, ready for heat. Then the refinery's heart reveals itself. The atmospheric distillation column rises over 200 feet into the sky, a steel tower that functions like a vertical sorting machine for molecules. Crude oil enters near the bottom after being heated to roughly 650 degrees Fahrenheit. At that temperature, it doesn't burn, it vaporizes. The vapors rise, cooling as they go, condensing at different heights based on boiling points. Heavy fractions fall back down. Lighter ones climb higher. This is where oil becomes many things at once. Diesel, kerosene, fuel oil, naphtha, and gasoline fractions separate naturally, guided only by physics and precise temperature control. Engineers monitor every degree, every flow rate. A few degrees too hot or too cold can mean millions lost in off-spec product. The tower never sleeps, and neither do the systems watching it. But what emerges is not finished fuel. These are raw fractions, incomplete and unstable. The lighter gasoline components lack performance. The heavier ones are too bulky to burn efficiently. To unlock their potential, the refinery must go further. Some heavy fractions enter vacuum distillation, where pressure is lowered so they can boil without cracking apart. This produces feedstocks for lubricants, asphalt, and chemical manufacturing. Others head into catalytic cracking units, where the real alchemy happens. Here, massive reactors use heat, pressure, and catalysts to break long hydrocarbon chains into smaller, more valuable molecules. Heavy oil becomes gasoline. Waste becomes profit. Hydrotreating units strip sulfur and nitrogen from the fuel, preventing pollution and protecting engines. Hydrogen flows through reactors under extreme conditions, bonding with contaminants and carrying them away. This step is invisible to drivers, but essential. Without it, modern engines would choke, emission systems would fail, and fuel would smell far worse than it already does. Only after all this does gasoline truly come into existence. Not as a single substance, but as a carefully engineered blend. Gasoline is not one molecule or even one fraction. It's a cocktail of dozens of components, each contributing something specific. Volatility for cold starts. Octane for knock resistance. Stability for storage. Energy content for performance. In blending units, automation takes over with near-surgical precision. Flow meters, sensors, and control systems adjust streams in real time, ensuring each gallon meets exact specifications. Additives enter in microscopic quantities, often measured in ounces per thousands of gallons. They prevent corrosion, clean injectors, reduce emissions, and protect engines under stress. Remove them, and modern vehicles simply wouldn't survive. Finished gasoline flows into vast storage tanks, waiting quietly for dispatch. From here, it moves outward through pipelines, railcars, barges, and tanker trucks. Within days, it may reach a service station thousands of miles away. When you squeeze a fuel nozzle and hear gasoline rush into your tank, you're hearing the end of a journey that began deep underground and passed through fire, pressure, chemistry, and control rooms glowing with screens. This refinery produces more than gasoline. Jet fuel lifts aircraft into the sky. Diesel powers freight, farming, and construction. Petroleum coke feeds heavy industry. Propylene supports plastics and manufacturing. Every usable molecule is extracted. Nothing is wasted if it can be burned, shaped, or sold. The location is no accident. Galveston Bay connects global shipping routes to America's inland arteries. Crude arrives from multiple continents. Finished products leave for every corner of the country. This single complex is a major artery in the nation's energy bloodstream. Shut it down, and the ripple would be felt far beyond Texas. And yet, the future presses in. Electric vehicles. Climate targets. Emissions regulations tightening year after year. The refinery adapts, investing hundreds of millions in upgrades, cleaner processes, improved filtration, and reduced sulfur output. The goal is not to disappear, but to operate cleaner, safer, and more efficiently for as long as liquid fuel remains necessary. Because despite the headlines, the engines of the world still turn. Trucks still haul food. Planes still cross oceans. Emergency vehicles still answer calls. And for now, gasoline remains the silent partner in almost every modern life. Inside America's largest refinery, there are no scenic views. No quiet moments. Only the constant roar of burners, the pulse of pumps, and the glow of flares against the Texas sky. It is not beautiful in the traditional sense. But it is powerful. It is precise. And it is relentless. This is where black, sticky crude becomes clear, explosive energy. Where millions of gallons are born every day. Where chemistry, physics, and human engineering meet at a scale few ever see. And the next time you turn a key or press a button and your engine comes alive, remember this place. Because somewhere in Texas, a refinery never stopped working to make that moment possible.